Trevor here. Today we're going to continue part 2 of our lesson on angles of regular polygons. Our learning target for today is that you can determine the measure of an interior and exterior angle of a polygon. And your success criteria is when you can define a regular polygon and use that to solve for those angles. Let's jump in. I wanted to show you the formula we talked about in last video, which is that the sum of the interior angles of any polygon with n sides is 180 times the quantity n minus 2. So we take the number of sides, take away 2 from that, and that would be how many triangles we could split it into, and then multiply that by 180 to find the sum of the angles. Let's use that in this problem with an octagon. I first want to find the sum of the interior angles of an octagon. I know an octagon has 8 sides, so I can do n minus 2, but in this case, n, I should put an 8. So 8 minus 2 times 180, which would be 6 times 180. Let me grab a calculator for that. We've got 6 times 180 is 1,080. Now that we know the sum of all of them, since it's a regular polygon, I can find the measure of one angle. Regular polygons have equal sides and equal angles, so I know that each of these angles is the same amount. There are 8 of them, so really what I can do is just take our sum of the interior angles and cut it into n spots. So I'm going to take that 1,080 and divide it by 8 to get 135. So each angle on the inside is 135 degrees. Let's use that with a different problem here. We've got a pentagon on the bottom and a triangle on the top, and I'm trying to solve for k down here. So let's see, I think my game plan is if I had this pentagon on the bottom, if I had every angle on the inside, I'd be able to solve for k. But I'm missing this one here. To get it, I can use the triangle above it to solve. So I notice this triangle is isosceles with the 2 markings, and that means that the base angles are congruent. So let's use that. I'm going to start with 180 for the triangle, and then take away the 64 for the top angle. I have 116 to split between the 2 base. So I've got 58 for each of those, so that means this angle is 58 degrees. And since it's supplementary with this other angle, I can just see what with 180 it becomes to. So that'd be 122. So now that we've got all the angles in the pentagon, including this marking here, which we know means 90 degrees, I can start with the pentagon's interior angle sum. So pentagon has 5 sides, that means it has 3 triangles, so 3 times 180 is 540, and then I'll start taking away the things that are on the inside. I'll start with the 90, so minus the 90 off, minus the 96 off, minus the 122, and minus the 88. I'm left with 144 degrees for angle K. Let's move on to another one. In this case, I'm going to show you something a little bit different. This is exterior angle. So we know interior angles are on the inside, exterior angles are on the outside. So given this regular hexagon meaning 6 sides, I want to find the measure of angle A. My mindset is if I can find this angle, I'll call it B, then I know that A is supplementary to it. And B is an interior angle. So if I can find the interior angle of this hexagon, then I can find its exterior angle that goes with it. So let's see, hexagons have 6 sides, so I'm going to do 4 times 180 to find the sum. And after I get that, I'll have to cut it into 6 pieces. And after I get that, I'll have to do 180 minus it. This is our game plan. I kind of worked from the inside out. So let's see, in the inside here, I've got 4 times 180 is 720. I'll divide that by 6, and that gives me 120, 180, minus 120 is 60. So my angle on the outside here is 60 degrees. We're going to notice something about exterior angles now. So each of these are congruent. They're all 60. And in this case, I want to try to find the sum of the exterior angles. There are 6 of them, as we know, and they sum to 360. Let's note that for later. All right, let's see if we can come up with a general formula for the exterior angles. So as we did in the last slide, we noticed that the exterior angle and the interior angle are supplements to each other. So as a reminder, to find the interior angle, we would take 180 times n minus 2 to find the sum first, and then we would cut it into n pieces. That's the interior angle. And the exterior angle is a supplement to that, so I could say 180 minus this whole thing. Now this formula looks kind of janky. Let me see if I can try to simplify it a little bit. Let me move my calculator out of the way. Let's distribute the 180 on top here. So I'd have 180n minus 360, and then each of those are divided by n. I'll write it out like this. That way I can notice that these I can cancel, and let's distribute the negative in. So I've got 180 minus 180. Double negative makes a positive, so plus 360 over n. The 180 minus 180 will go away, and I've actually got a really nice equation here for the exterior angles. So to find the measure of one exterior angle, it's 360 divided by n, which tells me that the sum of the exterior angles is always 360, no matter what. So we've kind of got four different things going on here. We've got the sum of the interior angles, which is n minus 2 times 180. We've got the measure of one interior angle, which is that we had in the last one, the sum, and then cut into n pieces. We've got the measure of all the exterior angles, the sum of them, which is always 360, and the measure of one exterior angle, which is 360 over n. We've got four questions I want to go through. The first one says, if the measure of an exterior angle of a regular polygon is 15 degrees, how many sides does it have? Well, we know that the measure of one exterior angle is 360 over n equals that angle. And we have the angle, it's 15. So I'm going to try to figure this out. I just have to switch the n and the 15 so I can find the amount of sides. So 360 divided by 15 means there's 24 sides. So this is a 24 polygon. Number 2, how many sides does a polygon have if the sum of the measures of the interior angles is 1,980? So the sum of the interior angles is n minus 2 times 180, and we know that sum is 1,980. Let's divide both sides by 180 to solve. On the left, I'd just have n minus 2, and on the right, I'd have 1980 divided by 180 is 11. Oops. I can add 2 to both sides to find out that the number of sides we have is 13. So this is a 13gon. Number 3, each interior angle of a regular pentagon measures 2x plus 4. What is x? So let's see, each interior angle. Okay, so the sum of the interior angles is n minus 2 times 180. And one of those interior angles I'd have to divide by n. That, they told us, is 2x plus 4. And we're trying to find x. Also, by the way, they told us it's a pentagon, so I actually know what n is. A pentagon means it has 5 sides, so I can put a 5 in both of these spots. And I think we're ready to solve. So let's work on the left side first. 5 minus 2 is 3, so that would give me 180 times 3 is 540, and then divided by 5 is 108. So this whole left side is 108. I can take away 4 from both sides, so 108 minus 4 is 104, and then I can cut it in half to get 52 for x. Last one. Number 4, the measure of 4 of the exterior angles of a pentagon are 57, 74, 56, and 66. What is the measure of the remaining angle? Well, I know the sum of the exterior angles is 360. So if I start with 360 and I start taking them away, I'll find the last one. So I'm going to take away 57, minus 74, minus 56, and minus 66. My last angle must be 107 degrees. That's it for today, guys. We're going to use these facts as we move forward, and we'll also find some other angles with polygons when we find area in the next video. See you next time.